Hope you all are doing well. Let us go ahead in remote sensing in GIS today. So we have already studied unit 1, we've completed it. We are in the unit 2. We have studied types and characteristics of the sensors. Let us now understand the concepts of monoband, multispectral and hyperspectral remote sensing. Okay, these are various references that I've used while making this presentation. So till now you are very well aware of that there is a platform which has a sensor. That sensor senses the electromagnetic energy which is reflected from the surface with which it interacts. Okay, so some part of the electromagnetic energy it gets transmitted, some gets absorbed and some gets reflected. So this some part is a particular wavelength. That particular wavelength represents the amount of energy which is getting reflected, absorbed or transmitted. Okay, so due to this we see various colors within the visible wavelength, and various energy is also reflected. Okay, likewise we see some plants to be green, some rocks to be black. Okay, maximum will be the absorption, minimum will be the reflectance, and the image will get darker parts. Okay, so we very well know what electromagnetic spectrum is. As of now we are revising it today. We have to learn some of the ranges. The visible range, it lies from 0.4 to 0.7 micrometer. The infrared range, it lies from 0.7 to 3 micrometer, and the thermal infrared, it lies between 3 to 14 micrometer. Within this 3 to 14 also there are two windows, 3 to 5 and 8 to 14 micrometer. After this comes the microwave from 1 mm to 1 m, and after that the radio waves which range from 1 m to kilometers. Okay, so these are said to be various atmospheric windows. That is, these bandwidths they can pass through the atmosphere. Okay, while getting reflected they get transferred or transmitted through the atmosphere, and they are received by the sensor so that we make a image. So they have various frequencies and various wavelengths. Now comes the concept of bands. If we mark various divisional lines between these wavelengths, these are known as bands. Say for the optical bandwidth, this is the width, okay, this is the band. It contains VIBGOR. V represents the violet color, and likewise various colors till red. If we mark a line between these, they will represent a particular wavelength. We can measure it in micrometers, right? So these are various bands. Within infrared, within ultraviolet, we can make different bands. The optical range itself can be called a band, or various bands can be made within this also. Okay, so these are bands. If these bands are marked with larger range, as shown here, it can be said to be low spectral resolution, because spectral word defines the color which we identify. Because while studying remote sensing, in the beginning we must have only understood the optical range. Okay, so we divided various colors in accordance to the bands. So our sensors, or that may be eye or any other sensor, the ability of the sensor to identify the variation in colors or the variation in the bands refers to the spectral resolution. So from there we have taken this word spectral. Okay, so the larger is the bandwidth, low is the spectral resolution. Smaller is the bandwidth, high is the spectral resolution. Okay, so these are bands. This is the low spectral resolution, this is the high spectral resolution. That means if a sensor has the ability to identify smallest ranges between the bands, it is known as it is known to have a high spectral resolution. That means it can, if the spectral resolution is between 700 to 750, the sensor will not be able to identify any of the variation between these two bands. It may identify the variation between these two, but not within this. Okay, the better is the resolution, that means it can identify variation within the bandwidths within this band itself. So it has high spectral resolution. So depending upon this ability of the sensor, that is the characteristic or the resolution of the sensor, we get a particular image of a particular area. So these various bandwidths can be identified depending upon the perception and the interpretative power of the user. Here we are seeing a diagram. This spectral signature which we get from the surface with which the electromagnetic energy interacts, the spectral signature is got after it is reflected. So if we see the reflectance in the y-axis and the wavelength in the x-axis, here it is representing the value of photo. What does it do? The reflectance is lesser for blue in comparison to the red wavelength, red band. Okay, likewise if you see for plants, a particular spectral curve is found in the plants always. Okay, always we get this type of a reflectance. What does this shows? This shows that the amount of energy reflected by the plants is more in the thermal bandwidth or the infrared bandwidth, and it is less in the visible bandwidth. You can see it here. You see it here that it is less in the visible bandwidth, okay, and it is more in the thermal bandwidth. So what is to be done whenever we take photographs, the images, whenever we take these images, we try to use a particular sensor having sensitivity to a particular atmospheric window depending upon our use or depending upon our requirement. So when we are studying the vegetation part, we should use infrared wavelength. Okay, likewise when we are studying the topography, we should use the wavelength of the microwave or the radar's wavelength. Okay, so till now we try to understand what different bands are. If we take a image in a particular band like shown here, this is the image taken in a red band. The variation in the amount of energy which is reflected is shown here. The maximum amount of energy is reflected in this part, minimum amount is reflected in this part. That means the object may be black. Okay, and the amount of energy reflected depends upon the angle with which it is interacting with the surface also. For here, as of here, I am just trying to make you understand that in one band a particular wavelength will be reflected and we get an image at one band only. Okay, likewise we can have various other images at different bands. This is known as the red, green and blue band as seen here. So we can take various images in microwave also, infrared also, ultraviolet and x-rays also. Here I am trying to show you an example which we can easily see with our eyes. So if we take 3 different bands and then combine and make one photograph, this is what we will get. Okay, if we take a single band, this is what we are going to get. For red band, for green band we will have a different image, for blue band we will have a different image depending upon the wavelength which is interacting, the wavelength of the band which is interacting and the resolution of the sensor. Okay, so our image has various pixels. These pixels have particular DN number which itself corresponds to the energy which is reflected. So this part has lesser energy and this part has the higher energy. Okay, so when more than, this is one band, mono band. Okay, more than one band means multispectral, multi-band. Okay, more than one band, there are three bands here, so this is multispectral remote sensing is giving you this image. Monospectral or monoband remote sensing is giving you this image. Okay, so multispectral remote sensing will have many bands, they may be more than three. And on the contrary, the hyperspectral, as the name is suggesting, it will have up to hundreds and thousands of bands. More will be the bands that are being identified, more will be the resolution power. Okay, so what do you understand by monoband remote sensing? It is the science of acquiring digital imagery of the earth material in one band. Okay, these are equivalent to those stereo pairs which you saw, which you saw in, which you were shown in your photogeology classes. Okay, you had seen that black and white color images there, the panchromatic images there. So these are monoband. Whereas the multispectral, in that you have more than three bands. In the hyperspectral, you have many narrow contiguous spectral bands. Okay, so while we are talking about hyperspectral remote sensing, what happens is we take the image also, and a process of dividing those larger bands into narrow bands takes place, the way a rainbow is formed. Okay, these are some of the hyperspectral systems. They say, for example, if we see this sensor Everest, this sensor has a range from 400 to 2500 nanometer. Within this it can make 224 bands. Okay, TRWIS 3, it can make 335 bands. So these are the sensors which can help us in doing hyperspectral remote sensing. Okay, so if we try to understand the difference between multispectral and hyperspectral sensing, it is on the basis of number of bands and the narrowness of the band. Multispectral data, it may have more than 3, that is 5 to 10 bands or larger. Okay, they have larger bandwidths. Whereas hyperspectral, they have 100 to 200 bands and they have narrow bandwidths. Okay, here you see the bandwidths are very narrow, whereas in multispectral the bandwidths will be larger. And if you talk about panchromatic, a completely much larger bandwidth will be there, from white to black. Okay, if we try to understand the application of monoband image, I already told you that these are images which we studied in the photogeology when you were in BSc. So they are very economical in comparison to the multispectral and hyperspectral images. These can be easily attained, and they give you a panchromatic view. They have better radiometric, this spelling is wrong here, this should be A, they have better radiometric resolution, I'm sorry for this. And then if we understand the application of multispectral and hyperspectral remote sensing, they help us in understanding where a mineral is occurring. Okay, we will discuss about this as we go ahead. Some part of the electromagnetic spectrum, when we use only that part, that band, it interacts with the mineral, and the amount which it reflects gives a particular spectral reflectance curve, like we saw for vegetation earlier. Okay, so we can study soil also, we can understand atmospheric conditions also, it is useful for military personnel also. We can understand oceanography, snow and ice, oil spills, and understand the environmental conditions also. So hyperspectral remote sensing is very useful. multispectral and monoband are also very useful, but in comparison to mono and multispectral remote sensing, hyperspectral remote sensing is more useful, okay, because it combines the imaging and spectroscopy in one single system. As I already told you, the way a prism, it deviates or it breaks the white light into various bands, likewise it uses the imaging and spectroscopy technique. But there is some limitation. If there is water vapor, it can cause significant impact on data collection, because water vapor will also absorb the EME which is reflected from the surface. Okay, thank you. Feel free to ask questions, and if you are asking only, then I'll get to know that you are understanding or not. So today in this lecture, what did we study? We understood the concept of monoband, multispectral and hyperspectral remote sensing. We understood that how some part of the electromagnetic energy gets absorbed, some part gets transmitted, and some gets reflected. The reflected part, it is sensed by the sensor, and these sensors, they can be having different resolutions. Depending upon the resolution of the sensor, the images that we get may be of monoband, of multispectral, or hyperspectral. It depends upon the quality of the sensor. Okay, so we revised the electromagnetic spectrum and understood various ranges in which visible, infrared and microwave waves fall, and then we understood what bands are, what are low spectral resolution bands, and within the bands what are high spectral resolution. Then we also understood the spectral signature of plants and got an idea to how various objects within the earth's surface will show different type of a spectral signature curve, okay, depending upon the composition of the substance on which the EME is falling, because it may absorb, reflect or transmit on the basis of that only, on the basis of its composition and the mineral structure, right? Mineral structure or the structure of the tissues, if we say it for the plants. Then we understood what the concept of monoband, that in a single band, if we take an image, then how it will be. If we combine more than 3 band or 3 band, then how the image will be, right? So we understood what a monoband is, what multiband is, and then we also understood what hyperbands are. So based on the bands, we are understanding the spectral resolution, so we can use the word spectral instead of band. So we speak about monoband or monospectral remote sensing, multiband or multispectral remote sensing, hyperband or hyperspectral remote sensing. Okay, so we understood the definitions also, and then we tried differentiating that how number of bands and the narrowness of the band is used to differentiate between multispectral and hyperspectral remote sensing, and then we understood the applications. Okay, so please feel free to ask questions. If you are not asking question, I won't understand that you are I won't get to know that you are understanding. Okay, thank you so much.